All right, guys, welcome back. We're going to hit Unit 10, Lesson 2, Data Distribution. If you're watching this, it's Thursday. So let's get into this thing and take a look and see what we have cooking here with it, you know. All right, data can be displayed in various graphs, including dot plots, histograms, and box plots. We're going to talk about all these things coming up. Dot plots are useful for showing center, the center of the data, and variance. All right, the spread essentially. The variability or spread in the data points describe how far apart the data is from one another. This can be represented by the range, right? And to find the range of the data is just big minus small. We're going to go over all this stuff and you'll see it. The median and the mean both represent the center of the data. All right, so this is important. The median and the mean. The median's when you find the middle number. The mean's when you add them up and divide by the total number to set. When the data is skewed, then the median, all right, is the best representation of the data, the median. So when it's skewed, when it's not symmetrical, when the data is symmetrical, then the mean, all right, is the best representation of the data, okay? And skewed is defined down here. Data can be taken from three different shapes. This is symmetrical data when it's all equal, a line of symmetry, right? So this side is equal to this side. So when it's symmetrical, we want to use the mean. When it's skewed right, meaning it's heavier on the left, and it's kind of opposite. This is confusing, I know. And it's skewed right, left, that means it's heavier on the right. We want to use the median of the data. That gives us a better representation, right? So that will give us a better representation of the data set, all right? Okay, so let me check and make sure that you can still see and you're in good shape. Let's go. All right, at a doctor's office, the pulse of each patient was taken and recorded. The data is displayed here. Okay, so when we look at this data set, all right, 64 beats per minute was the smallest and 80 was the biggest. So let's go through and answer some questions. All right, what is the lowest, all right, pulse? Well, that's two people had 64. So 64, right, and we'll call that beats per minute. What is the highest? 80 beats per minute. Okay. And then what was the most common heart rate? Well, if you look at all of these to see what the most common was, you could see that, this has the most dots above it, 70. 1, 2, 3, 4, 5, 6. So 70, all right, was the highest, and we'll call that beats per minute, right? And how many people had fewer than 76? Fewer. All right. How many people had how many people had a pulse over 76? Well, here's 76, just one person, right? So when we look at that, this is what we're doing. How would you describe the general spread of the data? Well, when we look at this, all right, how would I describe this? When I look at this, it's kind of symmetrical. It's kind of even. It's not perfectly symmetrical like this was, but when we look at this, if we drew this line, it's kind of even on both sides. All right, 80 is kind of what we call an outlier. It's spread, but it has a nice symmetrical data. So I'm just going to call that symmetrical. All right, and what else I notice is 70. All right, 70 beats per minute had the most. All right. Data distribution. We've talked about the shape of it. Skewed right, skewed left, symmetrical. When we're talking about the centers, we're talking about the averages. The median, we use the median when it's skewed. We use the mean when it's symmetrical. The spread of the data is big minus small, okay? And we have variability, which just means change or spread, and center and displaying the data. Okay, let's continue on to the second page here. And let me get set up here so that you can see how we look in there so far. We're in pretty good shape. All right. And let's take a little peek at it. All right, so analyze the data, all right, and the data, all right, and then complete the chart. All right, so dot plot A, dot plot B, all right? So let's look at dot plot A. Dot plot A is skewed right, okay? Dot plot B is almost symmetrical, so we kind of look at that. So let's see what we have in common here. Where is most of the data in dot plot A? Well, dot plot A, most of the data to me is between 1 and 2. So, all right. And on dot plot B, all right, 20 has the highest. 20 has the highest, but it has kind of like an even spread. But so it's spread out. How spread out is the data in dot plot A? Well, in dot plot A, you can see that our data is kind of chunk or clustered here from 0 to 5 with a peak at 1 and 2. So when I look at this, it's very close. The spread is very close, right? And and it's all really within 0 to 6. 0 to 6. Dot plot B ranges from 10 to 24, so it's really spread out. So we'll just put a ranges, right, from 10 to 24. So 10 to 24 is our spread. So it's clearly spread out more where this is clustered. Is the data grouped around the left, middle, or right in dot plot A? Well, when we look at this, it's towards the left of the dot plot. Here's our cluster, so it's towards the left. And we'll just put left. All right. And then over here, it's really not clustered. So, all right, it's not grouped. 20 is somewhat in the center when I look at this. So it's really just not grouped. Right? We don't have a good cluster there. So that's kind of just has an even spread throughout there almost. What could this data represent? All right. Well, this data could represent a lot of things, people that got the problems right, one person got none of them right, 5 got one right, or 6 got 2 and 3 got 3 and so on down the line. 1 got them all right out of 6. So if there were 6 problems, 1 got them all right, 1 got them all wrong, and then we have a nice spread. Over here, when we look at this, and I'm just going to write vary. And then over here, when we look at dot plot B, when I look at this, it could be free throws. I don't know. This person out of 24, 3 of them got all of them, or excuse me, 2 of them got all of the free throws. Out of 24, 3 of them scored 20. Out of 24, this represents 17, doesn't it? Remember, it's in between 16 and 18. It's 17, and so on. So it's going to vary as well. All right, let's continue down to the bottom. And now we're looking at data distribution in a histogram. So really, guys, when you look at a histogram, and let me make sure that we're okay with this, and we are. When we look at a histogram, really the difference between it and a bar graph is there's chunks of data going across, right? All right, so, the histogram showing the number of points scored in a game has what type of data of distribution? Where can most of the data be found? So the points scored in a game is this one right here. So the majority of the data is on the left from 0 to 19. So majority is 0 to 19. All right, and where can most of the be found? Most of that data can be found from 0 to 19, and it's skewed right? Why is it skewed right? Because there's more data on the left. The histogram showing the height of the pediatric patients has what type of distribution? Where can most of the data be found? Well, look at the intervals here. These are intervals of 5. So this is really 30 to 34, 35 to 39, and so on. So you have to understand that's still a histogram. They just wrote the bottom or the horizontal axis a little bit differently. All right, so just keep that in mind because I told you there's chunks of data across. But the majority of the data in this one is on the right from 45 to 50, so the data is skewed left. So the majority, all right, is 45 to 55, and it's skewed left. All right, because there's more data on the right. So anyway, data distribution, we talked about skewing data. We talked about the mean, the median. We talked about when to use that for your measures of center, the spread of data, and we've done a lot of different things here. Okay, guys, get to the homework.